So we're looking at these practice questions, and the way that I formatted them, one thing that AP wants us to be able to do is kind of identify similar situations between linear momentum and angular momentum. It's hard to wrap your head around angular momentum, but it's pretty easy to wrap your head around linear momentum. So they want you to be able to draw those connections, draw those parallels. So what I have on this sheet is us kind of drawing our parallels between linear and angular, looking at really similar cases. So let's just look at this first question. An astronaut and his oxygen tank are moving through space with a velocity of 2 meters per second away from the ship. So we kind of have these two objects moving at 2 meters per second away from our ship. Their combined mass is 85 kilograms, 75 for the astronaut, 10 for the oxygen tank. We want to know how fast must he throw the oxygen tank away from the ship to cause him to move backwards towards the ship with a velocity of 0.5 meters per second. So this is kind of our first case. Then we want our second case to be this thing moving back 75 kilograms, moving back at 0.5 meters per second, while the oxygen tank is moving 10 kilograms at some velocity. So we're going to follow that same exact thing that we've done before, where I'm going to list my objects over here. So I have astronaut, I got the tank, and we want to list out the initial momentums and the final momentums, and then eventually set those things equal to each other. So the initial momentum of the astronaut, and really astronaut and the tank, so maybe I'll combine them over here. They're moving together, so our initial momentum is going to be 85 times 2, mass times velocity. So we have mass of 85 times 2, which gives us 85 times 2 is 170. So our initial momentum is 170. That's equal to our final momentum. So our final momentum, we have two things moving. We have the astronaut moving in the negative direction. So let's list that as negative. So 75 times a negative 0.5. 75 times negative 0.5 is negative 37.5. And then the mass of the tank times the velocity of the tank. So setting those equal. Right, and I can add 37.5 to both sides. 170 plus 37.5 plus 207.5 equals 10V. Then I can divide by 10, and I get 20.75 is equal to V. And then what we're going to look at is a situation in our angular case that is really, really similar. So I'm going to pause it, and then I will get to this one in the next video, but it's going to be a similar situation. All right.